Welcome to day 6, converting polar equations. Today we're going to work with equations that are in Cartesian, rectangular, x and y's, and we're going to convert them to polars with r's and thetas, and vice versa, having equations with r's and thetas and making them into equations with x's and y's. So we have our big 4 here, and the idea is that we're going to use these guys as substitution. These big 4. Now, I know before we kind of said that r was equal to the square root of x squared plus y squared, and theta was equal to inverse tangent of y over x, which is all true, but we tend to use the full form of these equations. And a little bit of review. We have our trig identities over here, realizing that 1 over cosine is really secant and 1 over sine is really cosecant. Okay, first question. What does x equal 5 mean, and what does it look like as a graph? Well, it looks like as a graph, that's the easy part. I think everyone should know that it looks like this. So what does it mean? It is a vertical line in which every point has an x value equal to 5 and any y value you want. So this vertical line has points on it 5, 0, 5, 1, 5, negative 2, whatever you want to call. And since it says x equals 5, that is a Cartesian or rectangular equation. So what does it mean when I say theta equals 45 degrees? And what does the graph look like? Well, again, right here down through quadrant 1, this is 45 degrees, so it should look like this, but technically it goes on forever in both directions. It really looks like this. So this is theta equals 45 degrees. So that's called an oblique line, a slanted oblique line in which every point has theta equals 45 degrees and any r value. So 0, 45, 2, 45, negative 3, 45, and so on and so forth. So what we're going to do today is convert these equations that have r's and thetas into equations that have x's and y's, and we're going to manipulate. And we're going to manipulate so we can use one of the big 4 up in the top left. We want to rewrite things so we can substitute using these big 4. So like in the very first one, I see r equals 4 cosine theta. I don't see any r anywhere in the big 4. I do see an r squared, so I like having r squared. So I have to decide how I want to do r squared. I could square it, but then the other side would be 16 cosine squared theta, and that doesn't really help me. So you have to think about how can you get r squared. So besides squaring it, we can multiply everything by r, and r goes here, r goes here. We get r squared equals 4 r cosine theta, and that's very helpful because r squared is just x squared plus y squared, and r cosine theta is x, so this is equal to 4x. And then we have a nice result, and we have x squared plus y squared is equal to 4x, and that has gone from an equation with r's and thetas to begin with, and now has an equation with only x's and y's. I would also like to know, what does this graph look like? Now, I didn't put it on the piece of paper, but when you're done, you should have an idea what this graph should look like. Well, I cannot put x squared plus y squared equals 4x into my calculator, but I can definitely put r equals 4 cosine of theta into the calculator when I'm in polar mode. So I am in polar mode. R equals 4 cosine theta. And I think my window's already set up. And there we go. It looks like we get a nice circle. And there we go, we get a circle. So I'm going to go back to my... here. So it is a circle, but anytime you have x squared plus y squared equals whatever, that is always going to be a circle. So anytime, if you remember from geometry class, that is the equation of a circle. So I don't remember seeing secant as part of the big 4, so I'm going to rewrite this. Because I know it's really 4 over cosine theta. And I decide, well, I don't like cosine on the bottom, so I'm going to multiply it through. When I do that, I get r cosine of theta is equal to 4. I'm like, wow, r cosine is nice, because that I do have some substitution for. That's x equals 4. And hopefully everyone knows that x equals 4 is a vertical line. If you wanted to, you could go ahead into your calculator and put in r equals 4 cosine theta, and you will see that it is a vertical line. So for this next one, yes, I could rewrite theta as inverse tangent of y over x, but I'm just going to take tangent of both sides. So I have tangent of theta is equal to tangent of 30 degrees. I have a substitution for tangent. That's y over x equals, and tangent of 30 degrees is 1 over radical 3, or you could do radical 3 over 3, whichever one you want. Like, I don't really want x on the bottom, so I get y equals 1 over radical 3 times x, or if you want, you could say radical 3 over 3 times x. Either way, this is an oblique line with a slope of 1 over radical 3. It's a slanted line. So remember, going back to number 1, I like having r squared, and if I multiply by r, I do get my r squared, but the other side is 2r, and that doesn't really help me. But this one I can square it, and I get r squared is equal to 4. And I like this r squared business because every time I see r squared, I can just rewrite it as x squared plus y squared is equal to 4. I can go to my calculator and put in r equals 2. I think if you had an equation that r just equals 2, that means the radius is always equal to 2, that this is a circle. Again, x squared plus y squared is always going to be a circle. Okay, so we're going to go from x's and y's, and we're going to rewrite it as r's and thetas. And at the end, if possible, we want to rewrite it where it just says r equals. The other side was okay to have x squares and y squares and this and that, because some of these polar equations aren't functions, so you just can't have y equals every single time. So using the big 4, I do like x squared plus y squared. That just gives me r squared minus, oh yeah, the y value is just 2 times r sine theta is equal to 0. I'm going to add it over to the other side, so I have r squared is equal to 2r sine of theta. And then I said I could divide out by r. I don't want to take the square root. I don't really want the square root of something. I see they both have r's, and I get r is equal to 2 sine theta. Now, I should know that x squared plus y squared is going to be a circle, but I could put r equals 2 sine of theta in the calculator, and it should be a circle. I'm in my calculator, in polar mode, 2 sine theta, I hit graph, and there we go. It's a tiny little circle, but it is a circle. Next one, y equals negative 3. I think we know what that graph looks like, but we have the substitution for y sine of theta, r sine of theta equals negative 3. I get divide out by sine. I got r equals negative 3 over sine of theta, or better yet, negative 3 cosecant of theta is a better way to write it. And we should know that y equals negative 3 is a horizontal line. Next example, y equals the square root of 3 times x. I think everyone should know that that is a diagonal, slanted, or an oblique line, but I want to rewrite it as r's and thetas. Now, here's one way to do it. I'm going to divide by x. So I have y over x is equal to the square root of 3. If there's other ways to do it, you could substitute it for the y and the x, but I know I have some substitution for this. Y over x is tangent of theta is equal to radical 3. And then how do I get rid of tangent? I do inverse tangent to both sides, and I get theta is equal to, well, inverse tangent of radical 3, I put it in the calculator, I get 60 degrees. And everyone should know this is an oblique line, just like on the front page when we did theta equals 45 degrees was an oblique line. Well, theta equals 60 degrees is also an oblique line. So this one's a little bit different. We have x times y equals 10. Well, if I rewrite this, I could say y equals 10 divided by x. And what does that look like as a graph? Well, let's see what that looks like as a graph. Well, the first thing I have to do is change it back to function mode, because I'm going to use y equals 10 over x. Go to y equals, I'm going to clear that out and do, I could do the special key. 10 over x. See, now I want to hit that variable key, it says x. And I could just do zoom 6. And we get these split little branches. Basically, it looks like 1 over x. It's just been stretched out because it's 10 over x. And the name of this graph is called a hyperbola. So I'm just going to go to my basic substitutions of x is equal to r cosine theta times y is equal to r times sine of theta equals 10. Multiply it out, I get r squared cosine theta sine theta is equal to 10. I can divide out by cosine theta sine theta. I get r squared is equal to 10 over cosine theta sine theta. And I don't have an r there that I can divide out on both sides, so I will have to take the square root of everything. So when I'm done, I have r equals the square root of 10 over cosine theta sine theta, which I'll put in the calculator, but it is a very different equation. Now, according to this, we said it was a hyperbola. So let's see if we get the same looking graph. Let's see, we said this graph should look like this, according to what we did in function mode. Okay, I went to that mode. I'm going to change it back to polar mode. I hit my y equals alpha here. Oop, let me clear that out. I want the square root of, nope. I want the square root of, let me use that special fraction key, 10 cosine theta, close parentheses, sine theta, close parentheses. I'm just going to do zoom 6, see what I get. So, it drew it differently, but I got the same looking graph as I did before. It's just that, you know, it draws it using thetas instead of x's and y's. Okay, so this one has a lot going on. I see an x squared and a y squared, so I'm going to presume it is a circle. The first thing I'm going to do is expand it. What I mean by expand is by doing x minus 3 squared, and then do y plus 2 squared, by foiling it out, or however you want to call it. So I've expanded it out, and now I realize I have minus 9, minus 4, which is minus 13, so that's nice. I'm going to make it equal 0. I'm going to rearrange a little bit, because I know what I want. I see x squared plus y squared minus 6x plus 4y, and I'm going to move this over, is equal to 0. Those are nice. R squared minus 6r cosine theta plus 4r sine of theta is equal to 0. I'm going to add these two over to the other side. R squared is equal to 6r cosine theta minus 4r sine theta. And since everything has an r in it, I can divide everything by r, and I get r is equal to 6 cosine theta minus 4 sine theta. And I'm going to move it up a little bit. This is a circle, and not only is it a circle, hopefully you recognize the circle as a center according to what we have here, the opposites, 3 comma negative 2. And let's put this in the calculator, see if we get what we think we should get. So I typed it in my calculator while I'm in polar mode, and I'm going to hit, hopefully my window's set up correctly. Now it's a little oblong because I hit zoom 6 last time, so I'm going to go back and hit zoom 5 to square it up. And I think if I pay attention to this, I think 1, 2, 3, 1, 2. That does look like the center of the circle. I think it is right. In the last example, 3x plus 4y equals 2 is the basic form, standard form of a linear equation. You want to rewrite it in slope-intercept form. I did it on the right, so I have a slope of negative 3/4. I'm just going to use my plain substitution. That is going to be 3r cosine theta plus 4r sine of theta is equal to 2. A little bit different now because of this 2 on the other side. It's great when there's 0 on the other side because I can move things back and forth and divide by things. I'm going to have to factor a little bit. I realize they both have an r in it, so I have r 3 cosine theta plus 4 sine theta is equal to 2, and then I can divide by that all. 3 cosine theta plus 4 sine theta. And when I'm done, I have r is equal to 2 divided by 3 cosine theta plus 4 sine theta. And we already said that this is a linear equation. This is an oblique line. That is a slope of negative 3/4 and probably has a y-intercept of positive 1/2. So let's see if we get this in the calculator. So I typed this in the calculator, and I'm just going to hit graph because I know my window is set up correctly now. So draw it differently. But it does look like a slope of negative 3/4, and it does look like the y-intercept is negative 1/2. The reason it doesn't go all the way down here is because, remember, I hit zoom 6, so it has a standard window. That theta step is 7.5. That may be too big for this one. Maybe I have to set it up as 3. Let's see what happens when I hit graph now. It's going to draw slow. It takes off. And let's see what happens. Now we get the other part of it. Now it's not doing the top part, but you do see that it does look like a oblique line with a slope of negative 3/4.